All right, looks like we are recording the session now. Hello to everyone who's joined in. Hey, Mark, I see you. How's it going? Last few gulps of my coffee before we begin. Beauty. All right, I see a lot of familiar names. Welcome. Hello, everyone. Very warm welcome to our online training course. Make sure everyone's microphone's muted. I really hope everyone can hear me all right. Give me a thumbs up on the chat if you can. Excellent. This is the new normal now, where instead of meeting you in person, we become a part of your day through a little screen. So following the good response that we received to our last wireless and firewall trainings, we decided to bring a topic which has been frequently requested. So the latest DrayTek VPN solutions is going to be the final training for the year 2021. Let's kick things off now with a quick brief about me. My name's Java, and I'm an IT sales specialist here at Dialin Technology. I've been in IT for well over 15 years, doing B2B sales and business development. I've been talking to most of you since the last few years over the phone and via emails. And a lot of you would have met me virtually via the weekly DrayTek webinars that we run on our YouTube channel. So the course today is going to consist of background theory and a bunch of videos. But the kicker is that we're going to have a hands-on demo of the practical exercises that have been covered in the workshop manual. And the key purpose of the session is to equip you, our partners, our resellers, with the information that you need to become more productive in your workplace. Do remember to stick around at the end and fill out the survey and qualify for $100 off of the reseller price for one of the 3 new AX models. That's right, DrayTek's got new Wi-Fi 6 AX models out. That would be the 2865 or the 66 AX or the 2927 AX. The offer is limited to 1 unit per participant, and it's going to be valid till the end of next month. That's the end of January. Okay, so let's start off now by introducing the DrayTek team today. I'm going to pass you on to Harvey, Edward, Darren, and Boy. I'm going to tell you a little bit about themselves. Over to you guys.
Hi, guys. Thanks. My name is Harvey. I've been looking after the help desk and the RMA repairs for 4 years and more now. Today, I will show you some hands-on experience on how to set up some VPN tunnels. So I hand over to Edward.
Hello, guys. I'm Edward. I work in Island Technology for 5 years now, and I probably meet a couple of you guys through the ticket email system and RMA as well. And for today, my role is to mitigate the meeting session online. So yeah, I'm controlling it. And yeah, I'll pass you to our technical manager, Roy.
Oh, hello, everybody. Yeah, my name is Roy Pineda, and I'm the technical manager at Dialin Technology. And I've been here for about almost 14 years now. And I mainly look after the day-to-day operations of the support, and also we look after the things like the knowledge base and videos and training courses. So I hope you gain plenty of information today, and hope you enjoy it. So we'll go to probably Darren in Queensland. He can introduce himself.
No worries. Thanks, Roy. I'll be taking over for the second part of the workshop today, getting into LAN-to-LAN side of the VPNs. Yes, I'm up here in sunny Queensland. It is sunny at the moment. We're expecting a storm this afternoon. Hopefully that doesn't happen until well after this workshop's finished. Okay, that's about it for me. I'll see you in about an hour. And I think we'll hand over to Edward again now, or Dr.
That's
Jawa?
me.
Dr. Jawa. No worries.
All right,
Thanks,
back
Jawa.
to me. That was the team for the day. Thank you. And before we begin, I'm going to quickly go over some basic housekeeping items. So as I mentioned, please make sure that your microphones stay muted during the training session. We want to keep things as smooth as we possibly can. But if you do wish to make a comment, just raise your hand and we'll allow you to speak. You can always type a question in that little chat box on your right. My team, particularly Edward and Roy, are going to be looking at them, and they will be providing feedback during the session. During the hands-on demo that Harvey shows you, you can raise your hand if you want any explanation about what's being shown. And as I mentioned, this session will be recorded. It is being recorded now, so if you do not wish to be viewed in the same, just switch off your camera. So we are using Microsoft Teams, and in case you may not be familiar with the application, I'll just quickly go over some tips on how to use it. All right. I hope you can all see me fine. If I'm not visible, just tinker around with the screen, and hopefully it's going to be all right. So at the top of your Teams window, this is with the assumption that you're running the latest one. You're going to see a bunch of icons. So depending on the size of the window, in the middle somewhere, you're going to see 3 dots. Just click on that, and it'll show you all the other options available. The main one's, of course, the device setting. And in the newer versions of the Teams app, and even in the web browser version, the toolbar will appear if you mouse over the window. The icons tend to change their order with every new update, so hopefully you don't face too many issues there. So that's going to show you your audio, your speaker, the mic, and the camera if you're having any trouble with any of those. On the right, up top, you'll see icons for your camera and mic. If you want to turn your camera off or mute your mic, which is obviously by default, just click on those. You will, of course, be able to see and to hear us. Edward here has got an override to turn mics off, but we can't turn them on again. And on the left is the icon that shows you the participants. Just click on that and you'll see everyone present in the meeting. The next one along is the chat icon. I really hope that one shows up. Just click on that and you'll see on the right of your screen all the comments that are going on, and you can obviously add your own. Down the bottom where it says type new message, you can attach files and you can add links and stickers and emojis and so on. Just click enter to submit when you're done. And the third one along is where you can raise your hand if you want to ask a question or if you want to contribute to the session. The one on the far right is the one to select to raise your hand. And please be aware that we're still sort of getting used to all of this as well. So apologies if we miss seeing your hand raised. If that happens, please type your question in the chat box, and one of the other team members should respond to you there. So we will be following this schedule for the workshop today. After the conclusion of introductions, the two sessions are going to run for about 45, 50 minutes apiece, which is going to be followed by a 15-minute Q&A, general discussion, if you will. And if you like to grab a cuppa, we're going to have a 5-minute break between sessions 1 and 2. Okay, so part 1 of the workshop, which would be handled by yours truly. We will start off with some VPN basics, things like what is a VPN, the types of VPN tunnels, which includes a discussion of the process and the protocols. We'll look at some configuration examples and a bunch of hands-on demos. And after the short break, Darren will take over with the second part, where he will look at the LAN to LAN VPN options. And if you want to keep up, the full contents of the course are in our training manual, which has been shared with you. That's a valuable resource. Please refer to that. And if you want to look at the page references, you should see those at the bottom right-hand corner on each slide. Okay, so it's time to begin. Let's start by answering the most basic questions. Let's look at what a VPN is. So a virtual private network, otherwise a VPN, it basically provides a secure and low-cost method for computers in different locations to communicate with each other across the internet, much as the same as if they were on the same local area network. There's no need for dedicated links between two sites, such as a cable or a Wi-Fi link, to allow this secure exchange. And instead, computers can communicate across public networks or wide area networks, which would basically emulate the properties of a point-to-point private link. So VPN is basically an extension of a private network using links that are spread across shared or public networks, such as the internet. There's several excellent videos on YouTube, which you can watch later. This one in particular, which we're fond of, gives you a simple explanation of what a VPN is and how they work and what they can be used for. It is available on YouTube at the link that's shown on your screen. So talking about the term VPN tunnel, it is used to describe the connection that's between your computer and the VPN server, or the connection between VPN servers. It's essentially a communication channel, or call it a tunnel, which protects your data being transmitted within it from being accessed by anyone else. If I were to give you an analogy, it would be a road tunnel for a car, where the concrete tunnel itself will protect the car driving through it from the water or the earth above from crashing down. And as you're probably aware, a lot of businesses nowadays choose to adopt VPNs to share their resources with their partners and employees who are not based in the office at all times. And companies have begun using VPNs to outsource their work that enables them to lower their staff costs while maintaining the data security. So users would be allowing your employees to access email and other applications without having them to be physically present in the office, which is obviously very popular nowadays due to COVID. You can allow many employees to work from home to keep your business running even during the lockdowns. It's also a way for your branch offices to communicate and access the important files. A good example is that Darren is currently in Brisbane, and we're able to transfer calls to and from him using a voice over IP phone, or we can just pick up our phone to talk on his extension. It is important to emphasize that VPNs need to be secure, because data breaches not only lead to compensation and regulatory fines, but can leave lasting reputational damage. Files can be easily transferred to and from two different locations, as if all of the PCs were on the same local area network. There's point of sale systems, which can be run over VPNs, and it allows up-to-date inventory management, sales tracking, and reporting over multiple locations, all in real time. VPNs allow secure communication over the internet by encrypting all of the data, making it much harder for a hacker to eavesdrop on what you're doing. And avoiding geo-blocking, that is the message that this video is not available in your country. It's a popular use for VPNs these days, but it's worth doing your research before picking a provider or a package, because Netflix and other streaming providers they're onto this, and they tend to block connections from certain IP addresses, which they constantly monitor and update. Okay, so now I have a quick quiz question for you, just to make sure everyone's paying attention. So, can anyone tell me, what is a VPN? What is it used for? Just use the chat box to write your answer. You can use the chat box to add your thoughts. Just read through all the options here. What do you think is the right one? Here's looking at all of you. Edward. That's all right, David. Hope you're feeling better. Haven't missed too much. We're just talking about what VPNs are, and that's good. I see a bunch of E's. And of course, the answer is all of the above. So VPN's a virtual private network between two sites, and it is used to provide a secure and low-cost link between these sites, as well as extend your local area network. You can sign up with VPN providers to obscure your location and encrypt your data, as well as to get around the geo-blocking measures that are used by some websites. I'm just going to put aside the ethical considerations of that. One of the more common applications by small business owners is to be able to securely access their accounting database and other resources at the office when they're working from home. Similarly, during the pandemic and the associated lockdowns, a lot of businesses have been able to keep operating by having their employees work from home with the aid of a VPN, which is something that we'll probably now see happening a lot more as employees and employers have now seen the ease and the benefits of working this way. So here's a handy little table. It shows you a list of the number of tunnels that are supported in each router model from DrayTek. They start off at 2 for the low-end routers, the entry-level models such as the 2765 series, and it goes up to 500 for the high-end enterprise-grade flagship bigger 3910. The number of tunnels a router will support gives you a basic idea of the size of the network or the scale of business that they've been designed for. So at the top of the table, you're looking at routers that are suited for homes and small offices, while at the bottom, you're getting into enterprise territory. So we'll talk about the types of VPN tunnels now. There's two main types in DrayTek routers. The first is LAN to LAN, and the second is remote dial-in. So what's LAN to LAN? As the name suggests, they're used to connect two whole LANs to each other. For instance, a branch office or a home office or someone working from home with several devices such as a laptop, a tablet, their IP phone, that needs to connect to a head office for sharing resources. And through one VPN tunnel, many users or many devices can be connected to the same network over the internet. The users at the branch office or home can access the servers and, for instance, the printers as if they were on the head office local network. In this LAN-to-LAN mode, only one VPN connection is created, and all of the staff at the branch office can access the head office services through it. And at the same time, the head office staff can access the branch office services. One requirement that you need to be aware is that the two networks should not have the same subnet as shown in this little example, where you see the router A, the headquarters on the left, has been configured as the VPN server. It's got a LAN IP subnet of 192.168.1.0 and 192.168.3.0, while router B, which is the remote branch office, has been configured as the client. It's got the LAN IP subnet of 192.168.2.0, which is different from the router A subnets. The second VPN type I mentioned is the remote Dialin VPN tunnel. It's also called a host to gateway or host to LAN VPN. So here we have a single user who uses a VPN client. A VPN client is just a software that's running on a computer, and it's going to aid in setting up the VPN tunnel for communicating with the head office network. The client will use an IP address in the local subnet at the remote network. Do note that each remote Dialin VPN tunnel that gets created will count towards the total number of tunnels supported in the router. And different routers support different number of tunnels that I showed you in the table earlier. So if you have, say, the 2865 series, which supports a maximum of 32 tunnels, these 32 remote dial-in connections, it could be a combination of dial-in and LAN-to-LAN VPN connections. And most VPN clients will work for remote dial-in to a DrayTek router. The most common are the default VPN client that's built into Windows, or the DrayTek Smart VPN client, which is available as a free download. You can get it for Windows, for Mac devices, and Android. You'll find download link on our website, that's draytek.com.au, as well as on the App Store and Google Play. Okay, another quick quiz question for everyone. So can anyone tell me what are the two types of VPN tunnels that are used in DrayTek routers? Just use the chat box to write your answers. All right, any activity? There you go. Excellent. That's right. Excellent. Thanks for that. That's good. So most of you got that right. The answer is, of course, LAN-to-LAN and remote dial-in VPN tunnels. So let's talk about how these tunnels work, and also have a quick look at the VPN protocols. Now, here's a diagram that shows you a basic representation of how VPN tunneling works. We'll talk about step 1, where the data payload is sent from a PC to the destination network. In step 2, the sending router will append a tunneling header to the data packet. Just imagine that as a man who's putting the data into a locked briefcase, handcuffed to his wrist. Now, this encapsulated payload is sent across the internet to the destination router in step 3, which is basically that man traveling to point B. And finally, the tunneling header is removed. So the briefcase has now been unlocked and opened by the destination router, and the data payload is sent to its final destination in step 4. There are some tunneling protocols. They not only encapsulate the data, but can also encrypt it to further protect the confidentiality and the integrity of the information, as shown in the diagram, the routers at each end of the tunnel encrypt and decrypt the data as it is sent and received. So here's a diagram which shows you the different stages in setting up an IPsec VPN tunnel. Make sure you understand the different stages involved. It's going to help you in troubleshooting your IPsec VPN issues. So step one, which is interesting traffic. It initiates the IPsec process. Interesting traffic is just a term for traffic that has to be encrypted over the VPN connection. So effectively what we're saying is that host A has something that it wants to send to host B in a secure way. So the phase is initiated. The VPN is initiated. Now step two is called the IKE phase. One. What is IKE? It's Internet Key Exchange. It basically authenticates your IPsec peers, and it negotiates the IKE SA, which is the Security Association, which sets things up for negotiating the next stage in step three. Your step three is IKE phase 2, where the IKE negotiates the IPsec Security Association parameters, and it sets up matching security associations in the peers. Step 4 is liftoff. The tunnel is established. We've got data transfer. And step 5 is just shutting the tunnel down, which could be intentional, or maybe it's a problem with the internet connection at one end or at both ends, or maybe it's just a timeout. A lot of YouTube videos and articles are available which describe in great depth of how the IPsec protocol works. So do check out the knowledge base that's at draytek.com.au, or just Google around. In my experience, once you've done one using DrayTek routers, they're really not that hard. So DrayTek routers include the most common VPN tunneling protocols that are listed with no additional licensing requirements. You've got the BPTP, L2TP, IPsec, and all of the others. Even OpenVPN, which was added from firmware version 3.9.0 in DrayOS routers. Here's a quick look at the basic security features for some of these protocols. Up top, you see GRE, that's generic routing encapsulation, which is a pretty basic protocol that offers no encryption or peer authentication. We use GRE where IP tunneling without privacy is required. It's just simpler. It's faster. It's also used inside an IPsec VPN tunnel in DrayTek's VPN load balancing feature, which is going to be covered in more detail in future workshops. Next up's PPTP. It's going to add a bit more security, requiring a username and password to authenticate. It can be encrypted as well. L2TP will offer higher level of security than PPTP by adding an IPsec policy pre-shared key to authenticate. Finally, IPsec, which is the king of VPN security. It is generally the way to go for business networks. It uses pre-shared key with varying levels of encryption to authenticate. What you generally require is a static or a fixed IP address at both ends, but this can be worked around using DrayTek's aggressive mode IPsec VPN, which uses peer ID to authenticate the connection. Finally, SSL or Secure Sockets Layer VPN uses the same HTTPS protocol that's used by secure websites. What it means is that as long as the router will allow HTTPS traffic through, an SSL VPN should get through as well. It's great for remote dial-in users that are using ISP supplied gateways that have no idea how to configure, or sometimes the ISP may have locked the interface. There's fewer restrictions for the data encrypted through SSL when you compare it with a traditional VPN. The smart VPN client that I mentioned earlier has an SSL VPN option. You can actually initiate an SSL VPN using just a basic web browser, but the smart VPN client from DrayTek is the preferred way to go. Let's now look at the VPN configuration options that are available in the latest DrayTek router models. The DrayTek DrayOS routers provide a VPN configuration wizard, which guides new users through the steps to set up a VPN tunnel. The VPN client wizard provides step-by-step menu options to configure the client side of the LAN-to-LAN VPN connection. The VPN client will dial out and establish a connection with the server. We start off by selecting the VPN mode and the profile to use, then select the protocol. And in the last step, you just enter the VPN details. Pretty simple. So, of course, the good thing is that detailed knowledge of how VPNs work isn't necessary to be able to navigate this VPN menu. It's just a case of entering the address of the VPN server and then making sure the security method and the passphrases match at both the ends. The VPN server wizard is configured in a similar manner, except, of course, in this case, we're configuring profiles to connect in, which could be individual PCs or other devices using software VPN clients, or they could be other routers connecting via a LAN-to-LAN VPN. Now, more detailed configuration options would be available further down in the main menu under VPN and remote access. With the newer, later firmware versions, you'll see the VPN Matcher setup option as well. The first option there is the remote access control setup menu. This remote access control allows you to select which VPN services you want to run on your router. By default, they're all enabled, and any you don't want can be unticked. You should know that in later firmware versions, PPTP VPN is disabled as a security measure. You might want to untick any that might apply if you're running a separate VPN server that's behind the router. For instance, you may have a Windows VPN server on your LAN that's been configured to accept IPsec VPN connections. So in that case, you would deselect IPsec in the menu and then create port forwarding rules to forward the applicable port to your server. IPsec is usually UDP 500 and 4500. Alternatively, you could put your VPN server in the DMZ, assuming you understand the risks in doing that. There's quite a few application notes about port forwarding in the knowledge base articles on draytek.com.au. Looking at the next sub-menu, it is PPP General Setup. This only applies to PPP-related VPN connections, such as PPTP, L2TP, or L2TP over IPsec. This one includes global settings, such as the authentication methods for the VPN client and IP address assignments for Dialin VPN users. The next submenu is SSL General Setup. This allows you to select which WAN interface will accept the inbound SSL VPN connection. The default port, that's 443, can be changed if required. This setting is separate from the management port, which is the HTTPS port that's configured in the system maintenance and management menu. The server certificate is used for SSL connections, and it can be self-signed to use the router's built-in default certificate. The certificate can be used for SSL VPN server and the HTTPS web proxy. The IPsec general setup menu. This one's going to allow you to configure global parameters for remote dial-in users and the dynamic IP clients, that is LAN to LAN. Next is IPsec peer identity. To use digital certificate for peer authentication in either LAN to LAN or remote user dial-in connections, you may edit a table of peer connections for selection. All right, VPN Matcher. This one's a new feature that's been added to DrayTek routers recently. It can be used to establish a secure VPN connection between two DrayTek routers that are behind NAT. These can be routers connected to the internet via a 4G or via a 4G modem, which usually only provides a private IP address to the router's WAN interface. So what is VPN Matcher? It's basically a service that's provided by DrayTek Corp, and it can be used as the VPN Matcher service setting in the configuration menu as shown here. There's an application note with more details available down the bottom there, but we will be going into more details during second part of the workshop. And I believe there is a hands-on demonstration of setting up VPN Matcher that's going to be done by Harvey later today. Ah, there you go. All right, Roy's put up that knowledge base article there in the chat. Thanks, Roy. All right, next is OpenVPN. This provides many configurable parameters in the general setup menu, such as TCP or UDP and port number to construct the VPN tunnel. In the client configuration menu, details such as the remote server and the CA certificate details can be entered. The all too familiar remote dial-in user menu. This one allows you to create profiles for your remote users to be authenticated and connect to the router via dial-in VPNs. So the number of dial-in user accounts that can be set up are going to vary by the router model. This screenshot is from the new VIGA 2865-2866 router, which supports 32 remote dial-in accounts. As I mentioned earlier, just bear in mind that while you can create the 32 profiles, any LAN to LAN VPNs that are running are going to count towards the total number of simultaneous VPNs as well. So say, for instance, you've got 10 LAN to LAN VPNs that are running. Only 22 of the 32 dial-in profiles will be able to connect. If it's going to be a problem, you will need a bigger router. For instance, the VIGA 3910 can support up to 500 simultaneous VPNs. Now here's the configuration page. To create profiles for LAN to LAN VPN tunnels, each page will have 32 profiles. So for routers supporting more than 32 tunnels, there are going to be multiple configuration pages. And also with the latest firmware, we have the option to backup and restore the VPN profiles. Make sure you do that. The second last VPN and remote access submenu we have is the VPN trunk management. Here you can set up VPN load balancing or a backup VPN tunnel. Now, when setting up backup VPN mode, you'll need to have 2 VPN tunnels configured to connect to the remote site. Then select member 1 as the primary VPN and member 2 as the backup VPN tunnel. The router is going to constantly monitor the health of the VPN tunnel and will fail over to the secondary backup when the primary connection fails. To set up a VPN trunk, the LAN to LAN VPN profiles need to be configured first. Then you just select them as member 1 and member 2. Next, select the load balance option for the active mode. Now, briefly, as shown in this diagram, the VPN trunk management will allow us to load balance multiple VPN tunnels between sites where they are established over multiple WAN connections. This, of course, is going to provide redundancy as well as higher bandwidth pipe between the two sites. We'll not go into much detail in this training workshop, but there is an application note in the knowledge base as well as a video on our YouTube channel if you're interested to see how it works and how to set it up. I have the links on the screen and they're also available on the workbook. Just turn over to page 34. And Roy, being his generous self, has pasted them on the chat. Thanks again. Okay, the last one is the connection management menu. This shows the status of all VPN connections. The status is also displayed in the LAN to LAN and remote dial-in user submenus, which I showed you earlier. Green, of course, is nice. Green text means that it's up. Red means it's offline. However, the page will only show VPNs that are online. If you want to see more details about which VPNs are offline, you need to refer back to the LAN to LAN and the remote dial-in user submenus. All right, let's have a look at the configuration of Dialin VPN tunnels. So remote dial-in VPNs, they're used where a remote office worker needs to connect to the network, the head office network, to access resources using their PC or laptop or a smart device. So what do we do on the router side? We need to create a VPN profile and select the allowed dial-in type. Then enter the username, password, or the pre-shared key, depending on the protocol we want to use. And on the client side, we need to install and configure a suitable client, a VPN client. You'll find lots of clients out there for pretty much every platform and the type of VPN that you want to work. But I would recommend running with the Smart VPN client, which you know is going to work. It has versions for Windows PCs, iOS, and Android devices. So, step one, to make sure the required service or services are enabled. This is under the Remote Access Control Setup submenu. Those are all enabled by default, apart from PPTP in the latest firmware. So it usually wouldn't be a problem unless someone else has been poking at it. Step two of the router configuration is to go to the remote dial-in user submenu to create a profile for the user. Let's see what that looks like. And the final step of the router configuration is to enter the dial-in user details, which are the username and password for a PPTP or an SSL dial-in connection. If you're using IPsec, that would be a pre-shared key. You'll also need to select which LAN subnet to use for the incoming connection if you have more than one subnet available on the router. And down the bottom of the page, listing all of the profiles, you'll also find links to download the Smart VPN client for different OS. Now, what does the user do? The user will need to add those details into their VPN client. Windows 10 also has a built-in VPN client that caters to a number of VPN protocols. But of course, the one we recommend is DrayTek's Smart VPN client, which can be used to set up different types of dial-in VPN connections like OpenVPN and SSL. Well, pretty much everything, including IPsec and PPTP. The Smart VPN client has versions for Apple iOS and macOS devices. If you'd like more information about this, there are a number of application notes on the knowledge base on draytek.com.au that cover various scenarios of setup. There's a version that's available for Android devices as well, which is available for download from Google's Play Store. You're going to find all of these links under the support section on draytek.com.au. Let's look at another example of setting up a dial-in VPN connection using OpenVPN with the Vigor router's self-signed certificate. Using a self-signed certificate simplifies the process of setting up OpenVPN. The details are covered in knowledge base article number 7462. That's on the chat box now. I'm going to go through a summary of steps. There's obviously a few steps that are needed to set up an OpenVPN tunnel. First up, you check the WAN is online. You need to enable the OpenVPN service. Check the system date. Create a dial-in profile. Create a certificate on the router. Then you export the client config file. This will have a .ovpn as the file extension. You apply the OpenVPN server certificate in the SSL general setup. And you create a remote dial-in profile in the DrayTek Smart VPN app by importing that .ovpn file into it. That's it. Okay, what we were all waiting for. Time now for a little hands-on demo. I'm going to pass you on to the able hands of Harvey, who will go through a demonstration of how to create a remote dial-in OpenVPN tunnel using the router's self-generated certificate. If you wish to try the exercise later, there is instructions available in the workbook on pages 63 to 70. All right, on to Harvey.
Thanks, Java. I'll take over. That's crazy.
It takes a couple of seconds for the switchover. That's fine. That's Microsoft for you.
Yeah, Microsoft now prevents me from sharing. Oh, now I'm a presenter. Thank you. Okay, let me take over. Okay, that's my screen. Right, that's my 2866. That's the latest router we have. So what we're going to do is a remote dial-in VPN. You got a PC here with a smart client, and then he goes through the internet, goes to the router, and then access the headquarters. So I've recorded something for you earlier.
Today we will set up a remote dial-in VPN between a 2865 and using OpenVPN encryption. So here is our 2865 router. We make sure that the WAN is well established. Now we activate OpenVPN encryption. You are strongly recommended to remove those encryption that are not being used for security reasons. Since we will be using a self-signed certificate, we just make sure that the system time and date is okay. Next, we will create a remote dial-in user profile using OpenVPN encryption with a username and password. The idle time is set to be 0. Here is our profile one created. Then we move to the OpenVPN server setup. The UDP port is by default 1194, but you may customize it as you wish. Then you click on the generate button to create those 4 certificates below, such as the root CA, the OpenVPN server, the OpenVPN client, and the trusted CA. Right after that, we will export the client config file. We set the VPN as default gateway if necessary. Give a file name for the OVPN file, which will be used later in the Smart VPN client. Click export to do that. See the open for file appearing on the right hand top of the screen. Note the UDP ping is 10 and the UDP ping exit is 60 seconds by default. Finally, we will go to the SSL General Setup tab and select the OpenVPN server certificate and click OK to exit. Now it's time to jump on a remote computer to set up the smart VPN client. We will create a new profile called OpenVPN2. That's the easy part. Just import the OpenVPN file created earlier. It will populate the correct one IP and the correct port 11994. Then just type the username and password of the remote dialing user. Click OK and then connect. Here I set up a continuous ping on the VPN server. And once the tunnel is created, then the ping will start to get replies. Now you can see the replies coming in. Going back to the router on the VPN connection management tab, we will do a refresh and see that the VPN tunnel is up and with the correct VPN encryption. This concludes the successful OpenVPN tunnel setup.
Yeah. Right. Before passing on to Java, if you have any question, please feel free. All right, Java, you can take over.
Perfect. All right, back to me now. So if anyone wants to try this at a later time, we do have Dialin VPN connection exercises. I believe they're in the workbook on page 78. They're going to include step-by-step instructions that cover several different scenarios. So give it a go. All right. Let's have a look at some Dialin VPN troubleshooting tips, which should help you with some common VPN issues that you may come across. So the first one we'll talk about is trying to connect to an invalid IP address. When setting up your VPN client on your PC, you will need to specify the destination IP address or the domain name. This will need to point to a valid public IP address. Now, if the destination router is located behind a firewall or a NAT device, which is the case for a lot of 4G connections, the router will be allocated a private IP address, which cannot be accessed directly from the internet, even through DDNS, even though your DDNS will show a public IP address. So in the case where DDNS is configured to display the router's private IP WAN address as shown in the image, this will not be seen on the internet since private IP addresses are not routable on public networks. This will also not allow a Dialin VPN client connection to be established. So in the case where dynamic DNS is configured to display the router's private IP WAN address as shown on your screen, it will not be visible on the internet since the private IP addresses are not routable on the public network. This will not allow a Dialin VPN client connection to be established. So what do? The workaround here is to use the VPN Matcher, which I mentioned earlier. Of course, on supported Vigor models. We're going to talk about this in more detail in part 2. In some cases, the smart VPN client is unable to reopen after the initial connection. In some cases, the VPN app doesn't reopen if it has been disconnected or if your internet's dropped out. So how do you resolve this? Just click on the show hidden icons. That's a button in your system tray. That's number 1 in the diagram here. In step 2, You should then see the Smart VPN icon. When it's offline, it'll appear as gray. Just right-click on it, and you'll see several options. Step 3 would be to click on Connect. The Smart VPN screen will now appear on the desktop. Just click OK. It should connect. If all of this went well, the icon should now be in blue. Here's another one. Sometimes when you use a Smart VPN client to connect to the server, there's a message, access denied, because username and or password is invalid. It shows up even though the passwords match. Although the password used may look the same, it's possible it includes a special character in there which is not visible. So just need to remember that the username and password are both case sensitive. These have to match exactly to what's been set up on the VPN server. And in addition, the username cannot contain special characters such as a single quote, a double quote, or backslash. Now, here's another issue we came across. That is, the VPN user profiles are not being saved for Dialin VPN users in the bigger 3900 or the bigger 2960 routers. This one's actually caused by invalid characters that are used for passwords in the user profiles. DrayTek products use passwords for a variety of applications, and there is some variation to be aware of between applications and models. So unless stated otherwise, these characters are allowed and these are not. So full details of what is permitted to be used in passwords is going to be available in our application note that's highlighted there at the bottom. Now, the fifth item is how to avoid IPsec VPN dial-up failure. This one gets pretty frustrating. I know I've spoken to a few of you earlier. When you're working from home using an IPsec VPN connection from your computer to the company router, you may experience that the IPsec VPN fails to come up. Now, this will occur if the company router has multiple incoming WAN connections, which are configured for load balance mode. The IPsec VPN creation, it starts from UDP port 500 and will move up to UDP port 4500. Now, since two ports or sessions are used, the gateway router might regard the VPN connection as a different NAT session and try to auto load balance. What this will do is it'll result in the two UDP connections coming in through different WAN ports that results in VPN connection failure. So what is the solution? The solution here is to disable the auto load balance feature for the LAN IPsec traffic. In the latest firmware, DrayTek Vigor routers support disabling auto load balance for specific traffic via the advanced button in the WAN general setup page. To disable the auto load balance feature for the LAN IPsec traffic, just enter the IPsec VPN ports 500 and 4500 as you see on your screen. This is going to tell the bigger router not to auto load balance for the VPN data packets. Problem solved. Now, here's another one you may have come across. This one's a pest. Yeah, the Smart VPN client in Windows cannot be started. You'll only see the command window pop up, but after that, nothing happens. This is sometimes due to the application not being installed fully, or there's a problem with Windows. No surprises there. Could be a new Windows update that messes things up. But when it happens, there are three things you can try. The first one is to go to the program folder where your application's actually installed. This one's going to be under the program files x86 folder, as you can see here. Then run the smart VPN service.exe. Hopefully that solves it. Now, if that didn't do the trick, then within the command prompt, you can run the command sc query smart VPN service and just check the state. It should show stopped. If that's not the case, then you can try stopping it by using the command sc stop smart VPN service, then try restarting the client again. Hopefully that solves it. Last thing that you can try is if the previous steps are not working, there is a command task list. It should show the smart VPN client with a session number that's not 0. If it is 0, then run the task kill command with the parameters here to terminate the task and then try running the smart VPN client again. If everything else fails, just uninstall the smart VPN client, reboot the device and reinstall it. Just ensure you have the latest version of the smart VPN client, which includes improvements as well as several bug fixes. Okay, here's another problem. The smart VPN not starting. It can't find the VPP adapter. The smart VPN client from DrayTek. It requires the DrayTek virtual PPP adapter to provide the SSL VPN service. Ideally, the driver should have been installed during the software installation. If you see the error message can't find VPP adapter, while establishing the SSL VPN, you need to manually reinstall the driver on the PC. There's a bunch of steps that you need to follow. There's actually an article, I believe, the knowledge base article 5729 that covers a summary of all of these steps. Please refer to that. There's another issue we found. That is the SSL VPN not connecting to the Vigor 3900 and 2960. This is the error message that you're going to see on the screen. It's actually all of these have been covered in your workbook. I want to make sure we don't run over our time. So I'm going to skip through the next few and hopefully circle back to them at the end of the session. All right, moving on. There's 2 that we skipped. I'm going to circle back to these after Darren's concluded during the general Q&A. So quickly summarizing what we've done so far. We've looked at what is a VPN. We've looked at the types of VPN tunnels, how they work, and the protocols that are used. We've looked at the configuration options for setting up VPN tunnels, and we briefly went over a couple of config examples. This was, of course, followed by a hands-on demonstration of setting up the OpenVPN dial-up tunnel to a router by using the self-generated certificates. And we finished by looking at some Dialin VPN troubleshooting tips. Not bad for 45 minutes. All right, it's 1. We will have a short break now. We will come back in 5 minutes. And Darren's going to pick up where I left. The second part of the workshop is going to begin in 5 minutes. So please go ahead, grab a coffee. And during the break, if you have any questions, please type them in the chat box and we will respond to you. I see there's conversations going on there. So hop in and we'll see you in 5 minutes.
Okay, I'm just going to play a short video while we're having a break here. I'll just bear in mind there's usually a bit of audio lag with Teams. It's one of the bugbears. Now I should have the full version of this video up on YouTube in the next couple of weeks, hopefully. All right.
Coming. Yep.
Hi everyone, Darren from DrayTek Australia and New Zealand, and I'd like to introduce you to our latest series of routers, the VIGA 2866 series. Now the 2866 series is not a replacement for the 2865 series, even though the models and features are almost exactly the same. The main difference is that the 2866 series also supports G-Fast, which is a newer and faster type of DSL technology like ADSL, VDSL and VDSL2. Let's take a look. First up, we have the VIGA 2866. This one has no Wi-Fi but has all of the other features, including a DSL WAN port which can be connected to G-Fast, VDSL, VDSL2 or even ADSL. A switchable gigabit Ethernet WAN port which can be connected to any type of internet connection requiring one of those. If you don't need it for an internet connection, it can alternatively be configured as an extra LAN port. 5 gigabit Ethernet LAN ports to connect PCs and other devices, and 2 USB ports which can be connected to a 3G or 4G USB modem or a USB flash drive or hard drive for sharing files on a network or collecting syslogs, or you can connect a USB printer to make it accessible on a network, or even a USB thermometer to monitor environmental temperature and receive email or text alerts if it gets too hot or cold. If we compare it to the VIGA 2865, we can see it looks identical. Inside we have support for up to 32 VPNs, which can be either LAN to LAN or Dialin VPNs, or up to 16 SSL or OpenVPN tunnels. Hardware acceleration, 60,000 NAT sessions, a powerful object-based firewall, up to 16 VLANs and 8 LAN subnets, app QoS so you can prioritize different apps with a single click, and a whole lot more. I'll leave a link to the product page below so you can check out the full range of features and performance advantages. The VIGA 2866 AC has all of the same features but also includes 802.11ac Wi-Fi, which features 2x2 MIMO and offers up to 400 megabits per second on the 2.4 GHz band and up to 867 megabits per second on the 5 GHz band. It also features the latest WPA3 wireless encryption method, wireless WAN, Wi-Fi mesh capability and a hotspot web portal if you'd like to offer Wi-Fi to guests or customers. Around the back you'll find an on-off switch and antennas. Those antennas are removable and are an SMA type connector, which allows higher gain antennas to be fitted if you want to extend the range. DrayTek have the ANT1205 and ANT1207 available, or the directional ANT2520. The VIGA 2866 VAC is the same but also has a built-in analog telephone adapter for VoIP. You can connect up to 2 analog telephones into these ports to make VoIP calls, or connect a cordless base station with multiple handsets if you like. You can also connect those ports to an analog PABX system, just like standard PSTN lines, which is great for a small office to add a couple of VoIP lines to an existing phone system. The VIGA 2866AX model features the latest 802.11ax Wi-Fi standard, which offers distinct advantages in high-density Wi-Fi deployments. That includes OFDMA, which splits a single frame into groups of subcarriers, allowing multiple users to transmit simultaneously. Another feature in 802.11ax is BSS colouring. Normally APs have to take turns to transmit if using the same radio channel so that the data doesn't get mixed up. BSS colouring means that data from each source can be individually identified so that APs can now transmit at the same time on the same radio channel without having to wait their turn. 2 other models are featured which have built-in SIM slots to connect to 3G or 4G LTE connections. That's the same wireless network that mobile phones use to surf the internet. You can actually fit 2 SIMs into these, with the second one coming into play if the first one isn't working. The primary one goes in the bottom slot and the top slot will be the backup connection. The first of those models is the VIGA 2866L. Now this model doesn't have Wi-Fi to create a wireless LAN. Those antennas you see are for the 3G, 4G LTE connection. You might also notice 1 USB port instead of 2 on the front. The second USB port is sacrificed for the LTE modem inside. The second model is the VIGA 2866LAC. This one does have Wi-Fi and it's the same 802.11ac Wi-Fi standard as the VIGA 2866AC model. Okay, so that is DrayTek's VIGA 2866 series router range, which come with a 2-year back-to-base warranty. Alrighty. So assuming everyone's back, we'll get straight into it. So in this session, I'll be going into more detail about LAN to LAN VPN tunnels in particular. We'll start with an overview of what LAN to LAN VPN tunnels are. Then we'll look at the configuration options and some examples. We'll also have a hands-on demo using VPN Matcher, which Jawa mentioned in part 1. And finally, time pending, we'll look at some troubleshooting tips to help resolve some common LAN to LAN VPN issues. So let's start with a LAN to LAN VPN tunnel overview. A lot of this is recapping some of the things we covered in part 1, so I'll be going over it fairly quickly. But if I'm going too fast and you want to stop me, go ahead, just raise your hand, or you can just ask a question in the chat box, and I'm sure Roy or one of the others will get back to you that way. So LAN to LAN VPNs, instead of a single PC connecting to a network across the internet, LAN to LAN VPN tunnels are used to connect 2 whole networks to each other. So you might have a branch office with several staff members connecting to the head office, or maybe a home office with several devices like an IP phone, a PC, a tablet and a laptop that you all want connected to the main office at once. The connections go in both directions as well, so people on the network that you're connected to will be able to access any files or devices that you decide you want to share with them. As Jawa mentioned earlier, one requirement is that the 2 networks connected by LAN to LAN VPN can't have the same subnet. In this example, the headquarters on the left has a subnet of 192.168.1.0. There's also the marketing department down there on the bottom left connected to that router as well, and they're on subnet 192.168.3.0. At the other end of the tunnel on the right, our remote branch office has a LAN IP subnet of 192.168.2.0. So all of our 3 connected LANs have different IP address ranges, and that's necessary for this setup to work. Recapping the 4 steps of how a VPN tunnel works. In the first step, we have our data payload being sent from a PC to the destination network. In step 2, the sending router encapsulates the data packets with a tunneling header. Step 3, the encapsulated data is sent across the internet to the destination router. And finally, in step 4, the destination router removes the tunneling header and sends the data to the intended PC on its LAN. Using a VPN protocol, which also encrypts the data, makes things even more secure. How it works is much the same as the previous slide, only the data is also encrypted by the router at the sending end in step 2 and decrypted by the router at the receiving end in step 3. While it's in transit, the data is encrypted, making it very difficult, if not impossible, for anyone eavesdropping to make sense of it. Okay, so that's basically how a VPN tunnel works. Let's look at the process in a bit more detail. So when it comes to actually establishing a VPN tunnel between 2 routers, there's 5 main steps. These are, firstly, dialing, where the VPN client sends a request to the VPN server. The next step is peer authentication. Then we have VPN negotiation. This is where the VPN peers exchange messages about encryption and authentication, and both routers have to agree on all the parameters. And after this, the VPN tunnel is established and the data is routed. This diagram Jawa showed us earlier shows the steps involved when setting up an IPsec VPN tunnel. It uses the same 5 steps to establish the VPN that we just looked at. We have more details on the different phases on pages 9 and 10 in the course notes if you'd like to check that out further. Okay, quick quiz before we go any further. What's the main difference between LAN to LAN and host to LAN VPN connections? Is it A, LAN to LAN VPNs only use IPsec? B, LAN to LAN VPNs only connect 1 user at a time to the branch office? C, host to LAN VPN only uses SSL? Or D, LAN to LAN VPNs once established will connect a branch office to the main office? Please type your answer in the chat box there. It's multiple choice. If you'd like to answer in more detail, please feel free to put your hand up and we can switch over to you. Lots of Ds, no one else saying anything else other than D. All right. And the answer is, of course, D, yes. LAN to LAN VPNs, once established, will connect a branch office to the main office. Here's a recap of the supported VPN protocols in DrayTek routers that can be used for LAN-to-LAN VPNs. Those include PPTP, L2TP, IPsec, and SSL. In the latest firmware, OpenVPN can also be used for both dial-in and LAN-to-LAN VPN tunnels. And this table Joa showed us earlier as well shows the security features of some VPN protocols. GRE up the top is the most basic with no encryption, but that comes in handy in some applications. For example, DrayTek use it in VPN load balancing, which we touched on briefly in part 1 as well. Other protocols use different levels of encryption. PPTP on the second line there generally doesn't have encryption, but in DrayTek routers it uses MPPE. IPsec offers the highest level of encryption, so that's the one to go for wherever you can. Question there, what are the speed difference between protocols? Maybe Roy can answer that if there's a quick answer for it. One video, if you want to check out, I found gives a good explanation of how IPsec VPN tunnels work. You'll find it on YouTube, published by Micro Nugget. There's a link down there, which Roy might be kind enough to stick in the chat box for us as well, if you want to watch that later. Okay, another quick quiz. What tunnel protocol does not encrypt data? Is it A, GRE, B, PPTP, C, L2TP over IPsec, or D, SSL? Got lots of A's so far. A. Everyone's answering A. Yes, A. GRE, Generic Routing Encapsulation, is a basic protocol that offers no encryption or peer authentication. So we use this one where IP tunneling without privacy is required. It's simpler and therefore faster. If you ever set up DrayTek's VPN load balancing feature, you'll find it being used inside an IPsec VPN tunnel. Anyone who is thinking PPTP, you're not incorrect as such. PPTP generally has no encryption, but DrayTek adds Microsoft MPPE encryption to make it somewhat secured. We'll now look at the LAN-to-LAN VPN configuration options, starting with DrayOS routers. We briefly looked at this in part 1 of today's workshop, so I'll go into a bit more detail. First up, the wizard options, which we saw earlier. DrayTek provides a VPN client wizard and a VPN server wizard, which can be for dial-in users or LAN-to-LAN VPNs. These are great for new users and provide a step-by-step guide to set up VPN tunnels. Using the VPN client wizard in a LAN-to-LAN VPN, you start by selecting the VPN mode and profile to use, then select the VPN protocol, then in the last step, just enter the VPN details. If that's a bit blurry on screen there, you'll find it a bit clearer in the manual on page 16. When finished, you'll get a page similar to this, giving you a summary of the profile you just created. The VPN server wizard is pretty much exactly the same, but in this case you can create either a LAN-to-LAN server profile or a VPN server for remote dial-in users to connect into. You start out by selecting the VPN mode and profile to use, then select the allowed VPN protocols, and then finally the authentication settings. Once confirmed, all these details are saved to the profile. For more advanced users, about halfway down the main menu on the left side, you'll find the VPN and remote access section where you can manually configure VPNs with a lot more detail, and also check status down the bottom there under connection management. At the top of the sub-menus is remote access control. It pays to have a quick check of this one first to make sure that the required VPN services are enabled in the router. PPT is disabled by default, and I think maybe OpenVPN as well in some of the latest firmware releases. To set up LAN to LAN VPN profiles, tunnels, we need to go to the LAN to LAN menu option, as you can see here. Each page has 32 profiles, so for routers supporting more than 32, you'll have multiple configuration pages. This one here, you can see links along the bottom, which go all the way up to 200 profiles. If you click on an index in the LAN to LAN profile page, you'll see this page, which allows you to create a profile. Within each profile, there's 6 subgroups. Those are common settings up the top here, followed by dial out settings and dial in settings, which will appear depending on the mode selected. Further down the page, we also have tunnel settings, 6in4 settings, and TCP/IP network settings. We'll go over each of these sections in the next few slides. Okay, up the top, the common settings menu defines if the router should be the VPN server, client, or both. As we can see here, the call direction can be either dial out or dial in, or both. If it's to be a VPN client, that is dial out, we need to specify how it should start the connection and when it should terminate the connection. Idle timeout can also be selected. The default is 300 seconds. That's the time period the router will wait until it disconnects the VPN tunnel if there's no traffic happening. The ping to keep IPsec tunnel alive option in older firmware versions is now replaced with quality monitoring / keep alive. The ping to keep alive was best used just for diagnostic purposes because it would cause the VPN tunnel to repeatedly drop and reconnect. This setting is independent of DPD, that's dead peer detection, which in DrayOS models is enabled by default and can't be turned off. Pardon me. The DPD feature sends packets to the remote peer every 15 seconds. If it doesn't get a response 2 times in a row, the router will disconnect the IPsec tunnel. There's an application note for this. If you'd like more information, just go to our knowledge base on draytek.com.au and search for DPD. Roy's got a link to the search there. And here we have the VPN dial out settings that we use when the router is the VPN client. So first you need to specify the VPN type. IPsec is recommended since it provides the best security and performance. Next, we need to enter the IP address or host name of the VPN server at the remote site. We also need to specify the encryption and authentication methods to use. A couple of points to note here is that these settings have to match the settings of the VPN server, and it's recommended to use AES SHA-256 for the best security and performance when using IPsec. An option available in the latest firmware is to establish the VPN tunnel according to a time schedule. You can see down the bottom left there of that screenshot. Up the top right for dial out, always on mode is selected to provide a stable VPN connection that won't time out due to inactivity. The idle timeout value will automatically change to -1 seconds when you tick always on. But it doesn't do that for the other VPN, which we'll go into a little bit later. In the IPsec dial-out settings, you'll notice that we have main mode and aggressive modes. So how do you know which one to use? Well, where both the VPN server and VPN client routers have static public IP addresses, we use main mode. Main mode can also be used when the VPN client has a dynamic public IP address. Here we need to use the dynamic DNS for peer VPN server IP address. When the VPN client router is behind NAT, such as when connected to 4G, we need to use aggressive mode. This requires the use of the local ID or peer ID, which need to match on both the VPN server and VPN client. When both the VPN server and VPN client routers are both behind NAT, we need to use VPN Matcher, which we'll look at shortly. VPN dial-in allows the router to be the VPN server and accept Dialin VPN requests. For VPN dial-in, you'll need to select the dial-in option in the common settings section of the menu. We can also set the idle timeout to 0 so that the router won't drop the VPN connection. In this case, you can't select always on for dialing connections. If you try that, it'll automatically change the call direction to dial out. So to get around that, we just change the idle timeout to 0 seconds. At number 1 there, you'll need to specify the allowed VPN types and the remote ID for IPsec VPN connections. You can select multiple types if you want the user to use other types of VPNs, otherwise deselect the ones you don't want them using. At number 2, you need to specify the IP addresses for each end of the VPN tunnel when using main mode configuration, or use peer ID when one end doesn't have a static IP address. The third item to specify is the accepted policies. PPTP VPN just needs a username and password for authentication and is usually the quickest to set up. For IPsec, there's a lot more parameters that need to be entered. You also have to enter a pre-shared key for IKE authentication as well as the security method. I won't go into detail about these settings, but there are a number of application notes available in the knowledge bases at DrayTek.com and our site at DrayTek.com.au covering various scenarios for creating VPNs if you'd like more info. Just use the site's search feature if there's a particular aspect you'd like more information about. Okay, another quick quiz. When an IPsec VPN cannot be established, which of the following won't be the reason? A, the dial-out interface is wrong. B, the username and password are incorrect. C, encryption method is not acceptable. Or D, mismatched network IP settings. Multiple choice again, so type your letter into the chat box if you'd like to answer. If you want to contribute more detail, please raise your hand. Everyone's a bit hesitant with this one. It is a slightly tricky question. All right, we'll go straight into it. And the answer is B. Yep, the username and password are incorrect. IPsec uses a pre-shared key as well as the source and destination IP addresses for authentication, not a username and password. Another one, when do we need to use IPsec aggressive mode? A, if both sites are NATed. B, if one or both sites have a public IP address. C, if both sites use public static IP addresses. Or D, the VPN client has a dynamic public IP. Or E, the VPN client is behind NAT. Please raise your hand for this, or better still type an answer in the chat box. We've got a C, an A, an E, a B, a D. When to use IPsec aggressive mode? Okay, a few different answers there. Let's have a look. The answer is E, if the VPN client is behind NAT. Where both the VPN server and client are behind NAT, we have to use VPN Matcher, which we'll cover shortly. Okay, next menu item is the tunnel settings. This setting enables IPsec dial-out to use GRE over IPsec. This is mainly used in dual WAN and multi-WAN routers when setting up a LAN-to-LAN load-balanced VPN connection between sites. The main thing here is that both ends must be in the same IP subnet for communication. That's the tunnel local IP and tunnel remote IP. So a bit different than normal VPNs, which can't have a matching subnet. This is like creating a mini LAN inside the VPN tunnel. So the local end and remote end do actually have the same subnet in this case. The logical traffic setting is an optional function and ensures the data transmitted over the VPN tunnel is actually sent out from both sides. A hacker might be able to decipher IPsec encryption, but they won't be able to transmit data over the VPN. When using this setting, the remote peer will also need to enable it at their end for it to work. There's a new option in the latest firmware. This is 6in4 settings. 6in4 is a tunneling protocol that encapsulates IPv6 packets on specially configured IPv4 links. This allows the transmission of IPv6 packets from the local site to the remote site via an IPv4 VPN tunnel. And the last section we have is TCP/IP network settings. This allows you to enter the network details of the local and remote networks so traffic can be routed over the LAN VPN tunnel. The more remote subnet section allows the entry of additional remote subnetworks. In routing mode, we have the translate local network, which allows the same subnet to be used at each end of the VPN tunnel, and the router translates the subnet to a virtual IP subnet. I'll go in a bit more detail about this one later. When NAT mode is selected, we have the option change default route to this VPN tunnel, which forces traffic from the remote VPN connection to use this router as the gateway for internet connections. So that might come in handy in some applications. In this example, we show the settings to use for the local and remote networks. The local network IP address of the router on the left will be the setting for the remote network IP for the router on the right, and vice versa. With the more remote subnet setting, we add the IP subnets of the remote network we need to access. This will be added into the routing table as shown in this diagram. Here we added the IP subnet 192.168.22.0 to the routing table. The option create phase 2 SA is required if IPsec is used and the VPN peer is not a DrayTek router. An application for using the more subnet setting is when VPN routers are connected to a central VPN server and branch offices need to see each other, as you can see in this diagram. Here, each branch router will need to have the IP subnets of each of the other branch routers to allow communication between them. It's not necessary, though, to enter the IP subnets of the branch routers into the more subnet table of the core router here, since they are already directly connected. If you need more information about that, it's in the workshop manual on page 32. Okay, for remote networks that use the same IP address space, DrayTek have added an IP translation feature, which uses a virtual IP address to avoid routing conflicts. This feature is only available for IPsec VPN tunnels. IP addresses that are not defined in the virtual IP mapping list will be blocked from the VPN tunnel. This option you'll find in the TCP/IP network settings in the VPN profile, down in the bottom there at number 5. There's 2 translated types you can choose from, either a whole subnet or a specific IP address. Clicking on the virtual IP mapping button brings up a dialog to specify the local IP address and the mapping the virtual IP address. Once the VPN tunnels are established, the routing table is updated with a static route pointing to the remote network. The WAN interface is shown as VPN in the column on the right there, where it's labelled as VPN-1. Trunk management. We briefly covered VPN trunk management settings in part 1 of this workshop, so I won't go into much detail here. This slide is just to remind you that it is an option in the LAN VPN settings. Once the VPN tunnel is established, we can check the status in the VPN and remote access connection management menu page in the router as shown here. Down the bottom there, green text means that it's up and it is encrypted. If you see black text there, that means it's not encrypted. Okay, a quick look at the VPN menu options in Linux-based routers. Most of the functions available in DrayOS routers are also available in Linux-based models, but the menus just look a bit different. Here we have the main menu of a Vigor 3900. This one's since been superseded by the Vigor 3910, which has a DrayOS interface, but it's running over a Linux kernel still. But it looks the same on the outside as any other DrayOS router. So similar to DrayOS routers, you'll first need to check that the required VPN services are enabled under remote access control that you can see here. In the 3900, you could create up to 500 VPN profiles, which can be either IPsec, PPTP or GRE. Here's a screenshot of the configuration menu. You first need to select the VPN type. We've selected IPsec tab. Then we click on Add to create a profile or Edit to modify an existing profile. So here you can see we have 5 profiles here. And here we have the configuration menu for the IPsec profile. Under the Basic tab, we enter the IP address details and IKE protocol to use and IKE Phase 1 mode as well as a pre-shared key. The local ID and remote ID are used when aggressive mode is selected, and we use aggressive mode when one end doesn't have a static IP address. In the next tab, we have the advanced options where we can select and change various things, and you can see the 5th and 6th options allow some configuration for DPD, which we don't get in the DrayOS interface. Under the GRE tab, we can enable GRE for VPN load balancing. And under the Proposal tab, we have the IKE Phase 1 and Phase 2 proposal settings. The last tab under Multiple SAs allows you to add multiple networks to the VPN profile. Okay, let's check out a short video demo on setting up LAN VPN tunnels between 2 DrayTek routers using IPsec. This video is presented by Britty Thacker and is about 6 minutes long. It's a few years old now and features some older models, but the interfaces haven't changed too much since then.
Hello everyone. In this video, I'm going to show you IPsec LAN VPN configuration between 2 DrayTek routers. Here we are going to set up VPN tunnel between DrayTek Vigor 2760 and DrayTek Vigor 2860. So let's configure Vigor 2760. Log in to Vigor 2760 and ensure that at least one internet connection is up. For that, go to Online Status, Physical Connection. Here we can see that WAN 1 is connected. Now go to VPN and Remote Access, LAN to LAN. Click on Available Profile Index. Enter profile name for VPN and tick Enable this profile option. We are configuring Vigor 2760 as VPN server, hence we are setting up call direction as Dialin. Set idle timeout as 0 seconds to keep this tunnel open until it is terminated by remote site. Now go to Dialin settings section. Ensure IPsec checkbox is ticked. Enable Specify Remote VPN Gateway option and enter WAN IP of peer VPN device. Enter iKey pre-shared key. Select IPsec security method for the tunnel. Here we are keeping security method to its default value. Then go to TCP/IP network settings. My WAN IP and remote gateway IP should be set as 0.0.0.0. In this case, remote network IP is 192.168.1.0, with mask 255.255.255.0. Local network IP is 192.168.70.0 with mask 255.255.255.0. You can click on More button to add more than one subnet. Click OK to save the VPN profile. Now let's configure VIGA 2860. Log in to VIGA 2860. Default username and password are admin. We'll check internet connectivity first. WAN 2 is connected here. Now go to VPN and remote access, LAN to LAN. Click on available profile index. Enter profile name and tick enable this profile option. You can also choose WAN interface for VPN dial-out. We are setting VIGA 2860 as VPN client, hence we can set call direction as dial-out. Tick always on checkbox to keep VPN tunnel up all the time irrespective of traffic flow. When always on option is checked, you can also enable ping to keep alive and type a remote network IP here. In this case, VIGA router will try to reconnect to the remote IP when the VPN tunnel is broken. Under dial-out settings, select IPsec, enter server IP. This will be WAN IP of your VIGA 2760. Enter iKey pre-shared key. This should be same as we entered in first router. Select IPsec security method. Here we will select high data encryption standard without authentication. You can click on advanced button for customized proposal settings if required. Now you can go to TCP/IP network settings. My WAN IP and remote gateway IP should be set as 0.0.0.0. Remote network IP is 192.168.70.0 with mask 255.255.255.0. Local network IP is 192.168.1.0 with mask 255.255.255.0. Click OK to save the VPN profile. Now go to Connection Management to check the VPN connectivity. We will wait for a couple of seconds here. Tunnel is up now. You can select VPN profile from the drop-down and click Dial to manually initiate the connection. You can also check reachability by ping response. So let's go to command prompt of the PC, which is behind 2860. I'll try to ping 192.168.70.1, that is VIGA 2760 router. You can see that remote router is reachable. Thank you for watching the video. For more information, you can visit our website www.draytek.com.au.
Oops. Yeah, Brady also mentioned using ping to keep alive there, which we no longer recommend. We now have dead peer detection, which runs by default in the background and does pretty much the same job, whereas ping to keep alive had a tendency to cause disconnections and reconnections. It was useful for troubleshooting though. Okay, so to summarize what's required for LAN to LAN VPN tunnels, for the VPN client, we set the call direction to dial out. We configure the dial out settings and specify the remote network server IP subnet. For the VPN server, we set the call direction to be dial in and then configure the dial in settings and specify the remote network server LAN IP subnet. Okay, let's have a closer look at VPN Matcher. In some countries, local ISPs will only assign private IP addresses for the general user. That's because there's not enough public IPv4 addresses anymore, or the numbers are very limited. That's the case in Australia, where most USB dongles will now only give you a private IP address. That's numbers starting with 192. something or 10. something. This creates a major issue when it comes to creating VPN tunnels, because the Dialin VPN server will need a public WAN IP address in order to be accessed. DrayTek's VPN Matcher service works to resolve this. When both DrayTek VPN routers are registered with the same DrayTek VPN Matcher account, they can locate each other, allowing them to establish a secure end-to-end encrypted VPN tunnel between the two routers, even if the public IP is hidden behind NAT, or if it's dynamic. To use it, you just need to register the routers involved with their MAC addresses and subnets, and the stun server will keep track of the routers, whether they're behind NAT or not. It's designed for DrayTek devices only, but also includes any PC using the DrayTek Smart VPN client. A point to note is that VPN Matcher is limited to a maximum of 8 devices, but if you need more than that, you just need to contact us at support and we can arrange for the limit to be increased for you. DrayTek will need the username that you're using for the VPN Matcher installation, since that's linked to the VPN Matcher ID. The image here shows what you'll see on the VPN Matcher dashboard. Harvey will take us through how to set up a LAN VPN using VPN Matcher in detail shortly, but I'll give you an overview of the basics first. There's 4 steps to follow. The first is to go to vpn-matcher.draytek.com and create an account. Then register all your VPN Vigor routers with VPN Matcher and copy the router list key that's in the red box there. So you'll need that when it comes to creating your VPNs. Okay, so the next step is to go to the router and under VPN Remote Access, VPN Matcher Setup, and enter the vpnmatcher.draytek.com URL and that router list key. If you find the device registered to VPN Matcher is not online, try the Stun Server Detect button. That's that button in the middle there. And that should allow VPN Matcher to find your device. Now set up the VPN profile in VPN Remote Access, VPN Matcher Setup of both VPN server and client. Click on the Get List button to get a group device list in your account. Then click on Create Profile and enter the VPN details. Once the setup is complete, VPN Matcher will exchange the connection information, including IP addresses and ports of both routers, and establish the VPN. You can check the status in the same place for all other VPNs down under VPN Remote Access Connection Management, or just at VPN Remote Access LAN to LAN. Okay, I'll pass you over to Harvey, who will take us through it in detail. You can also find instructions in the workbook on pages 60 to 64 if you want to refer back to it later. You can also find this demo in the webinar we ran a little while ago, what is VPN Matcher and how to use it, available on YouTube at the link down the bottom there. All right, over to you, Harvey.
Thank you. So let me take over. Right. Here we have a small sketch of what we want to do. You will see on the right-hand side, you get a NAT address 192.168. And on the left-hand side, you get another NAT 110.124.29, something like that. So to bypass this situation, DrayTek has offered a VPN Matcher server. In fact, someone else mentioned Aussie Broadband. The USB dongle, automatically you get a private IP address, but now some ISP, even with the normal one connection, you won't get a public IP. But for the time being, if you call them and you ask for a public IP address, they will give it to you. And also, if you want a static public IP address, you have to pay for it, right? But sooner or later, that also will not be possible unless you pay for it. So let's go back to our demo. I've recorded something earlier, so I'll go through that. Okay, today I'm going to show you how to create a VPN tunnel between two DrayTek routers, which have the one IP hidden behind a NAT device, such as a USB dongle. So look at this one, 2862. You will find the LT is a 10 dot something, which is a private IP, and a 2865 also having a 192 private IP. So what we'll do now, we just log on to the VPN Matcher.com, DrayTek.com website, and you can create an account or use one which you have already created before. I have one, so I'm going to do it. You log in and you start to enter your devices, right? So I've already entered it for you, but I'll just show you how to do that. You put a description, like say 2862, MAC address, you go to you take the LAN MAC address, you copy and paste, just be careful. When you paste it, you have to keep the format with colon instead of dash, right? So I'll do that for you. You remove all the dash and then you put the colon and so on and so forth. And you select the model number 2862. And you set this as a VPN server, which means it's going to dial in. And the LAN subnetwork, which you have 192. This is 1.1 and dash 24. So 191.68. And select the /24 mask, subnet mask. So I'll show you by editing the existing ones. So I put in description, the MAC address is in the right format. The select model is there. You see, that's 9FD0. So it's 9FD0, set as a VPN server, LAN subnetwork, and it's done. So we do the same thing for the 2865 on the other side, and you get that, right? So this one is 9768 and 9768 MAC address. So one is a VPN server, this one is not a VPN server, so it will be a dial out. Although dial out does not need to have a public IP, just for the sake of this demonstration, we can have it either as a public IP or as a private IP, doesn't matter. It's been registered in the VPN Matcher. That's a router list key. We will use it in our setup, which now we jump onto the 2862 router. You go to the VPN Matcher setup and you enable it. You set the router list key. The Matcher server is as usual, vpn-matcher.draytek.com. Click OK. You click on detect a registered IP, public IP, and your network environment is good to use VPN Matcher. So click on the get list. The two routers that you have entered will appear, and you will get a profile which will be created, right? This is the existing one. What I'll show you here, and I just set to factory default. It's very easy, so we just in a blink we just create it. So now it's empty. We go to DrayTek first. We get our IP address. Say our standard router is ready. Get list. You get the list down here. Then you say create profile. While you create profile, you select the index. You take the first index. Profile name 2862. Just put LAC, and it's a Dialin. It's a server, so it's Dialin. The server address is already given to you. Push ahead key, I put DrayTek, then peer ID on the other side is 2865. I will use 2865 as the ID on the side, and all the rest is preloaded for you from the VPN Matcher. Right? You don't have to do anything, just click OK, and there it goes. Right? Immediately you go to LAN, you see it's already created and it's already activated for you. So it's a Dialin, that's the profile name. It's a Dialin down here. You will find the peer ID. By default, it gives you an IPsec. That's a peer ID and encryption, appreciate key, and all these one IP remote gateway. By default, it's 0, and the remote network IP is 20.0, and the local is 1.1. So we can jump on the other side also, and I will do the same thing. All right, now we jump to the 2865 LAC, and we go to the VPN Matcher, and you click on the get list, and then click on create profile. Now you recreate a VPN profile, and put the profile name. So this one is a client, so it's dial out. You'll find the server address has already been given to you. Appreciate key is DrayTek. Local ID, that's the one, the 2865, which we put in PID just to differentiate. I just put LAC up there, and all the rest has been seated. Specify VPN profile, because I didn't select the index, take an index, and there it is. It's done. The profile has been created, and you will see it's a dial out. Yep, the IPsec tunnel has been selected to you. The server host name has already been given by the VPN Matcher server, and all this local network and all that has been provided by the VPN tunnel. So you will see the profile has been created, is already online, and the connection management, the IPsec tunnel, VPN tunnel is ready to go. Right, that concludes our test. Just remember to remove the routers from the VPN Matcher if you don't use it. Sometimes you do test and then you just leave the routers there, and then one day you want to use it, say, oh, it's already been used somewhere. Right, here you are. If you have any questions, please don't hesitate to type in. Darren, up to you.
No worries. Thanks for that, Harvey. I'll just turn my screen back on. And there we go. Bring that back up. Okay, so onwards and upwards. All right, so sometimes things don't go to plan, so let's take a look at some troubleshooting tips for LAN VPN tunnels. Actually, we're running a bit short on time, so I'll just skip through these. You'll find them all in the workbook in section 6 if you want to have a more detailed look at them later. NordVPN connection issues. Most of those are caused by passwords that are too long and WAN MTU size. Passwords have to be less than 15 characters, and the default MTU in DrayTek routers is 1500. But if PPP or authentication is used, then you need to drop that down to 1492. Sometimes an even lower MTU value is required. And to find a suitable size, you can use the MTU path discovery tool in the router. You'll find that under WAN Internet Access menu for the WAN connection being used. Then click on Details page. Then in the MTU section, click on the Path MTU Discover button. That's down there near that red arrow. And that'll do its calculations and come up with an MTU size to use. Then just click on Accept and it'll update the MTU setting in the WAN connection for you. You can also adjust the VPN maximum segment size using the telnet command VPN MSS set, and the maximum MSS for each VPN protocol is shown here. That's also in the manual. One issue we've come across with multiple IPsec LAN to LAN VPN tunnels is using the same pre-shared key for all VPN profiles. Yeah, don't do that. Use different pre-shared keys for each VPN. Otherwise, IPsec uses the pre-shared key to authenticate the connection, and if multiple profiles are using the same pre-shared key, things get confusing. I've done this myself, and you'll find that sometimes it'll connect, sometimes it won't connect, and you'll spend half an hour checking pre-shared keys and so on. But that's not the problem. Other times it'll connect, and you'll get no data flow or heavy packet loss and that sort of thing. So yeah, don't do that. Use unique pre-shared keys for each VPN profile. Connections can't be made to a VPN server which has a private WAN IP address. We've covered this one with VPN Matcher and 3G, 4G LTE connections in particular. The VPN tunnel limit, if you only need 2 VPNs, then the lower end routers in the top line there, the bigger 2133, 35, 2765 and 2766 and so on, will do the job fine. If you need more than 2, then you need to go down lower in the table a bit. Unstable VPNs, that's where the connections are dropping out for some reason. The most common one is an unstable WAN connection. If the WAN drops out, then so will the VPN. So to check if this is the case, go to the online status page and have a look at the uptime of both VPN routers' WAN interfaces. If one or both routers' WAN uptimes seem unusually short compared to the system uptimes, then you might need to have a chat with your ISP and see about getting that fixed. The idle timeout setting, there's often some confusion about this one. For LAN to LAN profiles, any value greater than 0 will cause the VPN to disconnect after a period of inactivity. The default is 300, which means the router will drop the VPN connection if it doesn't detect any traffic over the VPN for 300 seconds, which is 5 minutes, and you can adjust that up or down as required. And idle timeout of 0 means never drop the VPN. However, for an always-on connections, there are some differences to be aware of depending on if the router is being set up as the VPN server or client. For dial-out profiles, that is, the router is the VPN client, tick the always-on box. Note that this will change the idle timeout to -1 seconds by default, and that's what we want to see there. The router will now not drop the connection if there's no VPN traffic flowing. But for the VPN server that's Dialin, we can't tick always on. If you try that, it will change it back to a dial out connection. So that's actually a handy way to remember which is which. So if you are trying to set up a VPN server and you tick that box and it swaps to dial out, then you know it's the other way around and you just need to type 0 seconds instead of ticking the always on box. So if you use these settings, that means the server will never drop the VPN connection. If there's an event that causes the VPN tunnel to drop out, then the client will always try to reconnect. You can find more information about idle timeout values in our knowledge base article, linked down the bottom of the page there. Ping to keep alive, we've mentioned. Yeah, don't use that one. We've got dead peer detection now, DPD, which does the same thing. So it's recommended not to enable that unless you're troubleshooting. If you notice an IPsec VPN tunnel keeps disconnecting at regular intervals, such as every hour, then the cause could be due to an IPsec rekey failure. This is usually caused by a mismatched key lifetime setting on both VPN routers, so make sure both of those match on both routers connected by the VPN tunnel. If it still occurs at the key renew time, then try using a shorter lifetime setting and see if that helps. But if nothing seems to help, then capture the VPN syslog and give us a bell at support to see if we can help you out. Another one is that the VPN tunnel is up, but there's no traffic happening and you can't access any services over the VPN. The first, try ping test to see if you can ping the remote host or PC, and check that ping isn't being blocked by the PC's firewall. After the ping test, the next step is to check the routing table on each router to make sure the correct routes are shown. You can find this under Diagnostics Routing Table in the router. You should see a route to the remote LAN via the interface VPN, as you can show in here, see here under the red line, or above the red line, sorry. If you can't see that displayed, then the next step is to check the TCP/IP network settings in the VPN profile. It should include the details of the remote network, similar to what we have here, where the remote LAN subnet is 192.168.11.0. Sometimes the problem might be because the wrong default gateway is configured in the PC. The default gateway should point to the router LAN IP address. Where a PC has more than one network interface, the traffic might be being sent to the wrong interface. That's the one not connected to the router and therefore won't go through the VPN. To verify if that's happening, use the traceroute command to see if the first hop is the IP address of the router. If it's not, you'll need to manually add a static route in the PC. You might have firewall policies that are blocking traffic over the VPN tunnel. A quick way to check that is to disable the data filter. That will bypass all the firewall rules. If the VPN traffic then starts to go through, you'll know that one of the firewall settings is causing the problem. Another setting that can affect VPN traffic is the load balance route policies which send the traffic to another interface. After checking the policy settings, you can run the route policy diagnosis to test. You'll find that one down in the diagnostics menu. Just enter an IP address for the remote side of the VPN tunnel to test. If you find a matching policy that sends traffic to another interface, that'll give you a clue where to look. Another quick way to check if a routing policy is the cause is to disable the route policy rules and check if the traffic then starts flowing over the VPN tunnel. Another one you might get no VPN traffic is if both routers on the VPN tunnel are using the same IP subnet. That causes a routing conflict. In the example here, both routers to the tunnel are connected to the VPN tunnel are using the same LAN IP subnet 192.168.1.0. One solution here, if you're using IPsec, is to translate the IP subnets to a virtual subnet that'll be used for communication over the VPN. You'll find that one in the TCP/IP network settings sections in the VPN profile. That's the translated IP down here. Translate local network enable and set your subnet there. You'll find more detail about this in Knowledge Base article 5202, linked down the bottom there, which Roy's already put in the chat box for us. And the last one is why we get no VPN traffic when we're using IPsec AH, but the router is behind NAT. IPsec with AH can't pass through NAT, so if any of the routers are behind NAT, you'll need to use ESP for the IPsec VPN tunnel. There's some syslog analysis there for further. I won't go into these because we're already over time, but you'll find them all in the manual. Okay, so in this session, we focused on LAN-to-LAN VPN tunnels using DrayTek routers. We started with a review of LAN-to-LAN VPN tunnels and then looked at the configuration options in DrayTek routers. We also looked at a VPN configuration example where we used VPN Matcher to set up a VPN tunnel between routers that are connected over 4G. And Harvey gave us a hands-on demo of that using showing us the configuration process. And finally, we had a very quick look at some tips to troubleshoot LAN-to-LAN VPN tunnels. Okay, so now we have 15 minutes or so if you have any questions. If you can't stick around, please fill out our survey to let us know how we went. Roy will stick a link to that in the chat box for us in a second. Yeah, please let us know what you liked or what you think needs work. And filling that out will also qualify you for $100 off the reseller price for either the bigger 2865AX, the 2866AX, or the 2927AX, which is valid until the end of January 2022. Thanks everyone for coming along today. We hope it was helpful in developing your knowledge of DrayTek's VPN solutions. Please do fill out that survey before you go, and if you're not subscribed to our newsletter to receive a heads up about our next workshop, please drop us an email to sales@draytek.com.au. Okay, I'll hand over to Edward to look after the chat session. Thanks everyone.
Thanks for that, Darren. All right, so we have another 10 minutes or so. I know we're running a bit over time, but if there's any questions you guys want to post, feel free to use the chat.
Maybe Ming would like to say a few words, our director.
Oh, I see. That's good. I see our MD is online too.
Yeah.
So
there's one question here on setting up a backup VPN at 4G. I think we have got an application out somewhere, but it's basically you set up the second VPN using the 4G, and then you set it up as a backup option.
Yeah.
Yeah.
You have to do the VPN trunking and then set as failover.
Yeah, that's right. It's under trunk settings. I'm not sure if there is an application. I've got to check if there is one, but it's an option under the trunk management for the backup.
Okay.
So there's a link to the workshop survey, the feedback form that's on the chat.
It's
Just
not
make
there
sure
yet.
you fill that one.
Let me see if I can put it in.
I think I've already put that on the workshop survey.
Oh, there it is there, yep.
Yeah.
It's in the chat box.
Yeah, if you click on it, what I'll do, I'll email everyone after in case they missed it with the link. And also I'll put the PowerPoint slides on the FTP site. And maybe once the recording is finished, perhaps give you the link for the recording to watch it later.
Excellent. Right. So our MD, Mr. Ming Lu, is online too. In case you want to have a quick hello, Ming, may you want to turn your camera on and say hello to all of the partners who came in.
你的 camera 不能够 turn on.
Okay. Hi, everybody. I want to.
Spotlight.
Yeah. Can you hear me?
The camera is still.
Turn on your camera.
Go ahead. Just put your camera on.
Okay. I can't.
That's all right. We can hear you. Go ahead.
Okay. All right. Okay. Yeah, I want to thank everybody for attending this online workshop. Since the early days, that is about more than 20 years ago, the VPN has come a long way. Over the years, the new technology and new protocols or new functions have come along. And so we figured that it's very important for us to update our knowledge and for this knowledge for our customers as well. Since VPN is a very important function for ICT. So today we learned a lot of new functions and new ideas. In addition to, also refreshing the basic concepts of VPN. So I want to thank our teams for their efforts, and thank our customers for your participation. And all the questions on the message box are wonderful. And some of them we have to take it on board, and we'll get back to you soon. We're still in the middle of a pandemic, and this new Omicron strain is a bit unknown at the moment. We are told that the symptoms are much less severe. However, we still want to play safe for ourselves and our families. So for this couple of years, we haven't been able to go out to different states, and New Zealand included. But we are hoping that in the year 2022, we will be able to conduct some in-class workshops in different locations, because we miss you people so much. We want to meet, we want to see faces. And so please don't forget to fill in the survey form, because those provide us with way forward for the future. Having said all this, everyone have a happy Christmas and New Year break, and play safe, and we'll see you again very soon. Okay, bye-bye.
Thank you, sir. So the entire DrayTek team wishes all of you peace, joy, and prosperity in the coming year. We thank you for your support and the partnership. It's been a tumultuous 2 years, and hopefully we will continue to work with you in the years to come. We wish you much success. So please stay safe and enjoy yourselves. If there's any questions that we may have missed, be just an email away. support@draytek.com.au is the ID. And if you want to have a chat with me, you know the number, 0298388899. sales@draytek.com.au is where you can reach me to have a chat about our new products. I do remember, I think earlier this morning, we did send out a newsletter as well for the tri-band access points that are on special. So in case you want to have a look at that, the AP1000C, along with your AX routers, please get in touch. There's plenty of stock available. Any questions that we need to respond to? Otherwise, we close the session for now. All right, there we go. All right. So this was fun. Thank you so much, everyone, for your time. Wish you a happy holiday season ahead. We hope to see you again in 2022 in one of our future workshops. Take care. Bye-bye for now.
Bye.
Okay, thank you. Bye.
All right, guys. Thank you for your participation.